when we think of science, the first thing that comes to mind is its capacity to have only like one truth, one answer, one formula. But like the world is filled with contradictions. Like science will be definitely contradicting to itself. And today it's my job to show you how diverse and beautiful science can possibly be by paradoxes. So, hi, I'm here to show you the paradoxes of the scientific world, the multifaceted truth of science, the one thing we thought had only one truth. So, first of all, what is a paradox? Simply, it's a contradiction to itself, kind of like an antithesis. If I told you I had an orange pen and a blue pen, you might think that I'd use the blue pen more, or I might use the orange pen more, one more than the other. That's really strange because they're both pens. They're both functional and they're both useful, but we give them different treatment even though they're the same item. So, yeah, basically a contradiction to itself. So, I hope that was a good explanation of a simple paradox. So, now I wanted to show you what paradoxes centralize around. How are they connected? Number one, time. For that we have Einstein's twin paradox. So Einstein's twin paradox was that if there's a pair of two identical twins, and twin A went to space for a while and then came back, you'll find that twin B has drastically aged because time is not the same everywhere. It's not even the same on Earth. So, despite them being identical, there's a clear difference in age. Number two, behavior. So, my example of the two pens. Despite them being two similar objects, differing only in like color, they're handled differently and you think of their utility differently. The third, probability. For that, we have Schrodinger's cat. So, if you put a cat in a box with a radioactive element, or gunpowder, or an explosive, anything that would potentially harm the cat, it'll either live or die. But you'll never know until you open the box and see. In case you didn't know, a thought experiment is just an experiment taken about by a pen, a paper, and your mind, unlike a lab experiment. So, Schrodinger's cat centralizes around the phenomenon of quantum superposition. So, quantum superposition is a theory that I'll try to explain really simply. So, imagine you're sitting at a table with another person opposite to you, and your perspective is of the entire room around you and that person, except for yourself. Now, imagine their perspective being of the entire room and you, but nothing else. So, those two existences are what I like to call different positions of you. Maybe not quantum superposition exactly, but what the motive of paradox is the paradox of Schrodinger's cat really is. The different possibilities of the cat being either dead or alive, but we don't know anything because we haven't opened the box. So, I have framed this paradox of Schrodinger's cat into a probability question. Let the live cat be LC, the dead cat will be DC. Let the explosion of the harmful substance taking place be EX, and the explosion not taking place will be NX. So all of the possibilities we have are LC, DC, EX, NX. So our favorable outcomes is to a number. The live cat and the explosion not taking place, a 50% chance. Now what we don't want to happen is the cat being dead and the explosion taking place, also a 50% chance. So we don't really know, it's a 50-50. But there is something really important to keep in mind. there is no possibility of having a live cat and an explosion taking place, of having a cat living with the substance that could kill it being exploded, or like harming the cat. There's no way the cat can live that way. And also, there cannot be a dead cat and the explosion not taking place. It can't just drop dead by itself, God forbid. So the beauty of the paradox is that we always calculate probability, as in probability of the event. But the thing is, we don't know if this event is really taking place or not. Okay, so enough about that. Let's move on to another paradox called the Fermi's paradox. This is not related to the unit of Fermi, just pretend that doesn't exist for now. So, Fermi's paradox. In popular media, we have a lot of attention on extraterrestrial life, such as interstellar, ET the extraterrestrial, alien, and much, much more. The contradiction of intelligent life being in the universe and up for grabs is the possibility for it to be real, but there's not enough evidence. Basically, a high possibility of there being aliens, Martians, anything, but there's no reason or backing for that wild assumption. So, this is just called astrobiology, the question if there's life on Mars, Venus, Jupiter, Mercury, you name it. Yes, so we don't really know if it's gonna happen, but there's a high probability of it happening, but we don't have any reason for it. Now for a really nice quote to end. The paradox of simplicity is that making things simpler is hard work. And I don't really believe in that, because making quantum physics topics easy is not that hard, but hard to some extent. So, yes, I don't think that's true, because I had a really good time explaining this to you guys. Thank you so much.